Average rate of change is how fast your y values are changing as compared to your x values. So delta y over delta x, which just means the change or the difference in y. So you subtract your y values and then divide by the change or the difference in your x values. So your average rate of change is often called your slope, which remember slope, and that pen's not working. Remember slope is often notated with that m, so that m represents slope. So to find slope from a graph, remember you can just find your rise over your run. But if you're only given 2 sets of coordinates, then you would do your second y coordinate minus your first y coordinate, and same for your x coordinates, and then divide those two answers. So we have a graph here to find the average rate of change between given points. So number 1 wants us to find the average rate of change between 1, 6, which is here, and 9, 10. So I could do rise over run. So if I done rise from 6 to 10, that would go up 4. So I went up 4, and then my run from 1 to 9 was 8. So 4 divided by 8, which is 1/2. So my average rate of change would be 1/2. Again, remember your average rate of change is the same thing as your slope. Okay, and then I'll show you how to do it with using this formula up here that we've used before, just to refresh. So we have the coordinates -3, 4, and 3, 7. So again, you subtract your 2 y coordinates. So we'll label this as x1, y1, and x2, y2. So we're going to subtract our y coordinates. 7 minus 4 over 3 minus -3. 7 minus 4 is 3. 3 minus -3. Remember, minus a negative just means add, so 3 plus 3 is 6. So that gives me 3 over 6, which is also 1/2. Okay, and then -9, 1, and -5, 3. So x1, y1, x2, y2. So 3 minus 1 over -5 minus -9. 3 minus 1 is 2. -5 minus -9, which is -5 plus 9, which would be +4. And 2/4 is also 1/2. So if you notice, every interval that we looked at all had the same average rate of change or same slope, because this is a line that's moving at a constant rate. Okay, this next section says using the formula, find your average rate of change between these points that are on the same line. So we don't see the line, we just are given the coordinates. So we just use that regular formula. So x1 minus y1, and you don't have to write this every time unless it confuses you, then I would write it just to make sure you're subtracting the right numbers. So y2 minus y1 over x2 minus x1, just to remind you. So 4 minus 7 over 10 minus 5. 4 minus 7, -3, and 10 minus 5 is 5. So my average rate of change would be -3/5. Okay, for number 5, go ahead and label these real quick. That's a 1. So 10 minus 13 over 0 minus -5. 10 minus 13 is -3. 0 minus -5 is the same thing as 0 plus 5. So again, I get -3/5. Okay, 22 minus 16 over -20 minus -10. 22 minus 16 is 6. And then -20 minus negative 10, which would be negative 20 plus 10 is negative 10. And then if you use your calculator or just simplify, 6 divided by negative 10 would give you negative 3/5. So in the conclusion, it says your average rate of change for a linear function is always the same between any 2 points that you're given. In other words, we can say that it is constant. So when you have a line that's not changing directions, it's just going in a constant rate, your slope is constant, therefore it's the same no matter what interval of points you are given. Okay, nonlinear functions, these would be like your quadratics, polynomials, when you have exponents in here, that's going to make our slope not constant. Okay, so find the average rate of change. Again, we see a nonlinear function graphed here, which is g of x is equal to the square root of x. So first it wants us to find the average rate of change between when x is 0 and x is 4. When x is 0, y is also 0. So I could say this is the same thing as 0, 0. And then when x is 4, my y is 2. So this would be the same thing as the coordinates 4, 2. So to find that rate of change, we're going to do 2 minus 0 over 4 minus 0. 2 minus 0 is 2, and 4 minus 0 is 4. 2/4 would simplify to 1/2. Okay, for B, it says find the interval x equals 1 and x equals 4. When x is 1, my y is also 1. And then we know when x is 4, the coordinates were 4, 2. So subtract our y coordinates, 2 minus 1, over the x coordinates, which is 4 minus 1. 2 minus 1 is 1, and 4 minus 1 is 3. No simplifying needed, so that rate of change would be 1/3. So it says which interval has the larger average rate of change, A or B? So we have 1/3 and 1/2. Sorry. Remember, 1/3 is the same thing as 0.3 repeating. 1/2 is 0.5, and 0.5 is the larger fraction. So interval A would be our larger rate of change. Okay, for number 2, we have function f of x in the table, and it wants us to find the average rate of change between these intervals. So we have x equals 1 and x equals 2. Well, when x equals 1, f of x, or y, remember f of x is the same thing as my y coordinate, is 4. So we could say this is 1, 4. And then when x equals 2, y is 9. So 2, 9. So then we're just going to subtract 9 minus 4 over 2 minus 1. 9 minus 4 is 5, and 2 minus 1 is 1. 5 divided by 1 simplifies to 5. Okay, B is interval 1 to 3, and we know 1 is 1, 4. And then when x is 3, we see that y is 16. So 16 minus 4 over 3 minus 1. And 16 minus 4 is 12. 3 minus 1 is 2. This can simplify. 12 divided by 2 is 6. So which interval has the greater rate of change? That would be interval B. Okay, number 3 says the table below shows the year and number of households in a building that had high-speed broadband internet access. So here are our years and then number of households that had the access. A wants to know the average rate of change between 2002 and 2004. So our year is the same thing as our x, and the number of households would be our y, or our f of x. So we're going to subtract our y coordinates first. In 2004, that would be 2004, 23. and 2002 would be 2002, 11. So that would be if I wrote it as ordered pairs. So we're going to subtract 23 minus 11 over 2004 over 2002. Or minus 2002, sorry. 23 minus 11 is 12. And between 2004 and 2002, that is 2 years. And 12 divided by 2 is 6. So that means the number of households with internet access increased by 6 households over those 2 years. 12 households over those 2 years, which was an average of 6 households per year. Okay, B is 2003 and 2005. So I'm going to look at 2005 first. We had 33 households. And then 2003, which we had 16. So 33 minus 16 would be 17. And 2005 minus 2003 is a change of 2 years again. And 17 divided by 2 doesn't simplify, so I could leave it as 17 halves, or I could say 8.5. So that means in that period, the households increased by 8.5 per year. Okay, 2004, 2006. 2006 was 42 households. And 2004 was 23 households. And then, of course, 2006 minus 2004. Okay, 42 minus 23 is 19. And 2006 minus 2004, again, is a 2-year change. 19 divided by 2 would be simplified in fraction form as a decimal. That would be 9.5. Okay, D, average rate of change between 2002 and 2007. So in 2007, we had 47 households. And then we know 2002 was 11. So 47 minus 11 would give me 36. And then this was a change in 5 years. So I could leave that as 36/5 or change it to 7.2. Okay, E wants to know which interval has the smallest average rate of change. That would be the lowest number. So if we're looking here, we had 6, 8.5, 9.5, and 7.2. 6 was my smallest number, so that would be the interval between 2002 to 2004. Okay, and then real quick, just to show you a different notation, sometimes you'll see your interval like this. So this just is talking about your x values, when x is 1 to when x is 2. So my average rate of change when x is 1, y was 1, so that would be 1, 1. And when x is 2, y was 3. So then, again, I can do rise over run, or I can subtract 3 minus 1 over 2 minus 1. So average rate of change would be 2. Okay, and then looking at this one, so we see it's doing different things at different places. So to find the average rate of change over the interval -6, -2. Well, when x is -6, my y is -3. And when x is -2, my y is +2. So again, I could do rise over run. So I'm going to do that on this one. I would have to go up 5. And to the right, 4. So that would be 5 fours or 1.25. Okay, my rate of change at -2 is 0. We know -2 is 2. and 0 is 3. So if you do rate of change again, you'll be going up 1 and over 2. So that would be 1/2 or 0.5. Next interval is 0 to 2. I don't go up and just go straight across. My y values stay the same. So 3 minus 3 is 0. And 2 minus 0 is 2. And 0 divided by 2 is just 0. So there was no rate of change because it stayed the exact same. Okay, and then the last one, rate of change over 2 to 5. 2 was at 3. And 5 is at 6. So if you do rise over run, that would be up 3 and over 3, which is 1. And then, sorry, there is one more, average rate of change over the interval -6, 5. So we know -6 was -3 and 5 was +6. So we could still do rise over run to go from -3 up to 6. None of my pens want to work. So that would mean I went up 9. So up 9, and then I would have to move to the right from -6 to 5, which would be 11. And that does not simplify or come out to a good decimal, so I would just leave that as my answer. So the average rate of change over that whole interval was 9/11ths, but depending on which section you looked at, it could have a different rate of change. So again, this would be a non-linear function. Okay, and then real quick for your assignment, okay. Sometimes you're just given functions, which would be your, like your equation. So it wants to know from the interval what x equals -2 to x equals 1. So I just need to evaluate this function. So when x equals 2, that means h of -2, sorry, is equal to 6 minus 3, -2 squared. -2 squared would be 4. Multiplication comes first. -3 times 4 would be -12. And 6 minus -12 is -6. So the coordinates for this point would be -2, -6. And then I want to check it at x equals 1. So h of 1 equals 6 minus 3 times 1 squared. We know 1 squared is 1. -3 times 1 is -3, and 6 minus 3 is 3. So the coordinates for this point would be 1, 3. So then I could just subtract. So since looking on a graph, x of -2 would come first, so I'm going to start here. So 3 minus -6 over 1 minus -2. 3 minus -6 is the same thing as 3 plus 6, which is 9. 1 minus -2, which is 1 plus 2, which is 3. And 9 divided by 3 is 3. So my average rate of change would be 3 for that one. Okay, then this is just like kind of what we've done. It's wanting to know the change in collection value between 1990 and 2010. So x, y. So change in y would be 143 minus 56 over 2010 minus 1990. And 143 minus 56. 87. And then 2010 minus 1990 is 20. As a decimal, it would run 4.35. And notice it says to the nearest cent, so that means I do need to have both decimal places. So that means it changed at an average rate of $4.35 per year.